Hi, my name is Jessica Forde, and I'm here to talk to you about Bayesian Nonparametrics. So I'm sure many of you have done clustering before, and so as you know, a lot of these algorithms require you to know the number of clusters in advance. So obviously the question is, if you don't actually know the number of clusters, how do we pick this number, often known as k? So often we might do something like we might just assume a certain value of k, say, okay, it's probably 3 or 4, or we might use grid search to say we know it's in between a number of, say, 3 and 10, and say, okay, let's just look through these and see how it compares across different metrics. But ideally, what we really want to do is learn the number of clusters from the data. So what we want to do then is to say that the number of clusters should represent the data, have an appropriate level of complexity, and be based on prior information. So Bayesian nonparametrics is one way to solve this problem by learning the number of clusters directly from the data. In the case of clustering, Bayesian nonparametrics is Bayesian because these clusters can be characterized by a probability distribution, and we can include prior information about the number of clusters and the characteristics of each cluster. And these clusters then are also then nonparametric because k is learned during the process of learning. For clustering, we use a stochastic process known as the Dirichlet process, which allows k to scale with the size of the data, includes prior information, and has a rich get richer property. So if we have new data coming in, the probability of this data being assigned to clusters is largely based on how big these clusters actually are. So Datamicroscopes is a library that's available through Conda. And currently we have 3 models, all of which are focusing on algorithms based off the Dirichlet process. We have the Dirichlet process mixture model, which is used for generic clustering. Compared to other libraries, we can actually specify what kind of likelihoods you want. So if you want a gamma-Poisson mixture model or a, let's see, a beta binomial mixture model, you can actually do that. We also have the hierarchical Dirichlet process, which is a algorithm used for topic modeling if you don't actually know the number of topics in your data. And we also have the infinite relational model, which is a stochastic block model, which, as far as I know, has not been seen in a Python library available through Conda. And this can be used for clustering relational data, such as social networks. We have some real-world examples, such as clustering the MNIST dataset for digit recognition, topic modeling with the Daily Kos, and community detection with the nround email corpus. And if you have any more questions, you can go to our website, which is datamicroscopes.github.io. You can go to our repo, Datamicroscopes, to install our library. And if you want to learn more about the Dirichlet process, you can go to github.com/tdhopper, which is a colleague of mine, and he has a bunch of IPython notebooks on the Dirichlet process. Thank you.